So we are going to continue our vertex form today and graphing it, but now we also want to talk about comparing it to our parent function of y equals x squared. So let's look at our first graph here. It says graph the function and then compare it to the graph of f of x equals x squared. So again, we're not going to change anything from what we did yesterday. So here is h, and then I don't have a k, which means I'm just going to add that 0, and that's my k. So my vertex is going to be at opposite of what I see for h, which is going to be a -1 and then 0. And then we make our table of values. Put my -1, 0 in the middle. 1 less than -1 is -2. 1 more than -1 is 0. And when we plug that in, we're going to have 3 times -2 plus 1 squared. And that's going to give us 3. And then we know because it's a mirror image, the other side is also going to be 3. If you want to calculate it and check it yourself, just plug 3 in, or 0 in, sorry. And you will notice that you get 3. So let's plot our graph. So if I plot my vertex, it's going to be left 1 and I don't move. And then I'm going to go left 2 and up 3. And then I don't move in the x direction. And then I just go up 3. And there is my graph. So comparing it, well, if you look at your equation, the 3 and the 1 are the two parts that are different than our parent function. So that 3, that a value, if a is bigger than 1, you're going to stretch. If a is a fraction where it's small number over a big number, you're going to compress. So in this case, a is 3. This is our a. And so since a is 3, a is bigger than 1, which indicates that this is stretching. So we would write that we are stretching by 3. And then the other part that we need to look at is that 1. Well, remember our h tells us if we are moving left or right. Well, because h is -1, that indicates that we are moving left 1. And if you look at your graph, if we look at our graph here, didn't the vertex move from 0 left 1? So I would write that it moves left 1. And then if we want to, we could identify the vertex, but we don't have to there. So that's what that one is doing. Let's look at the next one. Okay, so it says graph the function and compare it to the parent function, x squared. So again, we need to find our h and our k. So this is h, this is k, this is our a value. So our vertex, our h says -6, which means h is going to be a +6, and then k is a -1. So if we make our table, put our vertex in the middle, 1 below 6 is 5, 1 above 6 is 7, and then let's plug it in. We're going to go 1/4 times 5 minus 6 squared minus 1, and that's going to give us -3/4. And then if we did it again with 7, I'm going to also get -3/4. So let's plot our points. If we plot our vertex first, 6, -1 means I'm going to go right 6 and down 1. And then 5, -3/4. So I'm going to go not quite to -1. And then 7, -3/4 would be the same. And then there is our graph. So now we need to compare it. So we're looking at our a, h, and our k values. So our a is 1/4. Well, if you remember from here, if a is 1/4, that's a smaller number. 1 is smaller than 4. So we have a small number over a big number, which means I am compressing. So on this problem, I would say that we are compressing by 1/4. And then if we look at our vertex, this tells me left movement, or left and right movement versus up and down movement. So since it's a positive 6, and if you look at your graph, we went right 6. So I'm going to say right 6. And then we went down 1. And that would be the description. Let's try one more. Okay, so here we have, here's our A, here's our H, and then our K, we don't have anything, which means it must be 0. So my vertex opposite of H is going to be a negative 9 and then 0. So then let's make our table. Put our vertex in the center. 1 less than 9 is negative 10, and 1 more than 9 is negative 8. And then let's plug it in. We have negative 5 times negative 10 plus 9 squared. That gives me negative 5. And then if I do it here, I'm also going to get negative 5. So let's plot our points. Our vertex is at negative 9, 0, which means I'm going to go left 9. And then I don't move, so there's my vertex. And then negative 10, negative 5, I'm going to go left 10 and down 5. And then for negative 8, negative 5, I'm going to go left 8 and down 5. So here is my graph. So uniquely, because of our A value, when we look at our A, H, and our K, our A is a negative 5. So if A is negative, that means that you're going to open down or be what we would call reflected. So because of that negative 5, and you can see on your graph it is opening down. So we're going to open down. But another word for that would be reflected. And then if we look at our vertex, we went left 9. And then we didn't move anywhere. And then the other part we need to look at is our A. We've taken care of the negative. When you see that, you have to look at it as a negative and a 5. So if you go back up to this A value here is negative 5. There's two parts to it. One is negative and one is 5. So this negative here, right here, that's telling us that we're opening down. But the 5 means we have to go back to what we talked about earlier with our A value here. So 5 means A is bigger than 1, which means that I am stretching. So the 5 tells me that I'm stretching by 5.